Hi, welcome to today's talk of the Offensive Security course. My name is Carsten Tellmann and I work for GData, a local antivirus company, and we are supporting this course. And as most of you know, we are normally going to our company afterwards and have a little dinner there. Today we want to make a different thing. We want to go to the Christmas market, and if you want to join us, if you want to talk to the speaker in detail about some of the topics he will present us, or if you just want to talk to the organizing committee or just want to drink some Glühwein at the Christmas market, all of you are invited, and would be nice to see some of you. We will meet at 8 o'clock in front of the main station, and a special amount of drinks is for free, so first come, first serve, I guess. And without further delays, I think you will introduce yourself. Have fun with the talk.
Thank you. Hi, I'm Jonas Magazinius. I will just quickly switch to my presentation instead. So I will give you a presentation that is based on my latest paper, which is still in submission. So I'm actually a little bit uncertain what about the intellectual property rights and so on. So maybe you should try to keep this quiet. Still a secret. Crossing origins by crossing formats is the topic. First, I want to say that I'm a PhD student at Chalmers University. I study language-based security. Programming language-based security is, some people question what part of security is language-related, but programming language-based security focusing on web application security in particular. I'm also a co-leader of OWASP Gothenburg. We arrange some events each year, I think 6 last year, with a number of international speakers, among others. Can't remember the names at the moment. It's just anyhow. I'm also available on Twitter, so if you are interested in any of the topics, then you can follow me and be more up to date with my research. I'm also a father since roughly 1 year and 3 months ago, and that is a whole new thing to adapt to, and I'm still trying to balance the whole fathership and not having as much time for the occasional hacking session, late night hacking session. So, but I'm adapting, and it's working out fairly good. So I wanted to just briefly mention what took me here, and it started when I started my PhD and focusing on web application security. Then Slackers immediately popped up as a great forum for discussion on web application security related topics. And on this forum I met Mario. You should be familiar with him, I guess. Later we met in person in OWASP AppSec Research when I was presenting a paper, and he won a ticket to go there. And we started out, battling a little bit, trying to make the shortest quine on Slackers and so on in JavaScript. And later on, we decided to work together on Deutsche Post Security Cup, which was mutually beneficial. That indeed led me to the CCC 27 and the talk by Julia Wolf, "Oh my God, what the fuck PDF." And this talk was a great inspiration for this work, actually. So that, in a sense, took me here. So language-based security is the greater topic, and it's using programming language theory to deal with vulnerabilities in code, both finding and mitigating security vulnerabilities. We do static and dynamic analysis. In my case, in the web browser, it's mostly dynamic. We monitor the code in runtime as it's executing, and we focus on information flow monitoring, trying to find out where information is coming from, where it's going to, and making sure that information does not leak across origins. I work with mashups mostly, but this is a byproduct. This talk is a byproduct of my research because in such a heterogeneous environment as the web, it's not enough to focus only on JavaScript. So we started looking a little bit into other environments where JavaScript is executed, other dynamic environments on the web. The result is this paper and this talk, and it's joint work together with Billy Rios, quite fairly at least well-known security researcher who's now working at Google. The work is submitted to HCCS, but has not been accepted yet, and we don't know when exactly it will be accepted. So, but we should have the announcement before the end of January at least. So to give you a setting for this talk, I'm going to mention some related work. And in 2008, Billy Rios worked on the GIFAR attack, which and in parallel, this was discovered also by Petko D. Petkov, or PDP. And also we're going to look a little bit at cross-origin CSS attacks, which is documented by Chris Evans, among others, and content type sniffing attacks. So looking at GIFARs, it's a combination of a GIF image and a jar file in one file. Since GIF images are parsed top-down, and content that exists after the trailer is completely ignored by the interpreter, you can fit another file, a jar file, which is based on a zip archive, which is parsed bottom-up. So the zip interpreter will recognize the zip file or jar file and ignore the top part, everything before the header. And that way you can combine the two, and you can upload it. So, for example, the attacker in this case would upload the GIF or GIFAR to a vulnerable website. The user or the victim would then visit the attacker's website, which embeds the GIF but interprets it as Java. And the class will be executed in the context of vulnerable.com with the credentials of the victim. So this was an interesting attack, and it was actually in 2008 selected as the, I think, top or most influential, something like that, attack of the year. And then cross-origin CSS attacks. In this attack, we inject a minimal amount of CSS syntax into a target HTML page. Just a little bit, we need a little bit before, so we basically need two injection points. So we need to inject something before what we want to extract and something after what we want to extract. And then the attacker in his page uses the other HTML page as a style sheet and can extract from his own page from the style sheet when the victim visits the web page. he can extract from the style sheet some of the arbitrary HTML content which was loaded in the context of the user. So it would look something like this. So the user visits attacker.com, which embeds CSS from the vulnerable site. And also in this request injects these pieces of CSS. The CSS will then become the style sheet of the web page, and in the CSS there will be part of this vulnerable.com web page. And content sniffing attacks by Adam Barth, it relies on the browser's content sniffing algorithm. So when the server provides an unknown content type, the content is matched against, or I shouldn't say unknown, but a content type that is not native to the browser. Then the content is matched against a number of signatures to try to determine which content type this is and if it can be interpreted by the browser. And if a match is found, then it will be interpreted as that type instead of the type that the server submitted. So the attacker in this paper can create a chameleon file, which is both some unknown format and HTML with enough HTML to trigger one of these signatures. And the result is that it will be interpreted only as HTML and will be able to execute code in the context of the site. So the attacker would submit some, for example, PostScript, and when the user requests that PostScript, it will actually be interpreted as HTML. So what we usually do in the academia is generalize. How can we generalize this? What do these three attacks have in common? Yes?
They combine two different types of content.
Exactly. So the ability to reinterpret content as in a different format than it was intended, it's really based on the context where it's interpreted, but that is the key. And so, for example, to interpret something as CSS, we use the link tag, and if we want to interpret it as Java, then we use the applet tag. Similarly, if we load something with the script tag, it will be interpreted as JavaScript. And if we load something in an iframe, the content sniffing algorithm will determine what it will be interpreted as. And even more so, the object and embed tags allows you to this arbitrary interpretation based on the type attribute. So you can set the type attribute to the content type that you want it to be interpreted as, and it will execute the plugin, and the browser will rely on the plugin to know how to deal with the content, regardless of what type the server actually used. So this takes us, so this general definition can be explained as a polyglot. And the definition of a polyglot in normal or in general, in general terms, is a person who speaks several languages. Or in a programming language setting, it's a program that is valid in multiple programming languages or multiple compilers. We try to use a slightly broader definition than that. We say that a polyglot is content that can be interpreted as multiple formats. We see the interpreter as a compiler of sorts, and the format as the programming language. So here's a small example that is both HTML and JavaScript. And what it does is the script tag loads itself as JavaScript. So we can actually look at that. And it will look like this. Not very fancy, but it gives you a sense of how that might work, the polyglot. So if we want to do something more fancy than that, and I see I missed the example too. There should be, there's, for example, 16 different language polyglots available on Wikipedia. And that could be used in very different ways, I guess. So then we consider malicious polyglots, where one format is benign and the other is malicious. And we then, what can then happen is that we can verify that the file is of a particular format. We can verify that it's benign. But when we actually use it later on, it will execute in a malicious context. So the preferred format characteristics in a malicious polyglot would be that it's a commonly available format, that it provides tolerant parsing, so it allows you to mix two formats in a nice way, and with powerful capabilities. And the question is, what kind of format fits that? Well, we'll get to that, I see. So the attack vectors for a malicious polyglot would be either syntax injection, where we inject something with syntax from this malicious format to create cross-origin, cross-origin leaks, or so one example would be a cross-origin CSS attack, or cross-site scripting is sort of a syntax injection attack, even though you inject this, a document with its own syntax. Similarly, SQL injection, you don't create the polyglot, you inject the same format, but it's similar to cross-site scripting and SQL injection. Or you can attack it as in a content smuggling attack, where you upload this. Instead of injecting something existing, you upload a benign format and then reinterpret it as malicious, such as in the GIFAR attack, and equally in the content sniffing attacks. And then what can we do with this? How can we exploit this? Well, cross-origin leakage in the sense of CSS, the CSS attack, where we extract sensitive user information across domains, or cross-site request forgery, where we forge request with the credentials of the victim. How powerful this is depends on the malicious format, the capabilities of the malicious format. So finding a suitable format then. The portable document format, PDF, is standardized in ISO 32000-1. It's a container format, so it's, you can embed related resources, for example, font files or images, which means by design it can contain foreign syntax. It allows that, and this sort of requires an error-tolerant parsing, so that the embedded files do not interfere too much with the syntax of the PDF. And it's got powerful capabilities. For example, and I should have asked actually which ones you knew about, but display text, of course, possibly rendered 2D and 3D graphics that's built in, and animations. And you've probably completed a form or two in PDF for printing. But then you can also launch commands via the launch action. it's somewhat restricted in that the user will see an information box that the PDF is trying to execute a command. But as have been already shown, you can create this message that the user, when it tries to display the command that is going to be executed, you can actually pad that with a short message to the user that this file is encrypted. You need to click OK in order to read the file, or something like that. It can also execute JavaScript and embed Flash. And this is an interesting property, because you can, if you don't have Flash installed, but you have Adobe Reader installed, then you have Flash installed, because Adobe Reader has the full implementation of Flash. So, and also it's not updated as regularly as Flash is, which means that if you're running Adobe Reader, you're actually running an old version of Flash that is vulnerable to multiple security vulnerabilities. Lately there have been quite a lot, so it's been updated quite regularly, and I think though that the latest Adobe version has the latest Flash, but that's more by chance than by actual design. And it can issue HTTP requests when it's embedded in the browser. And then it will use the cookies of the browser. Isn't that a nice feature? It makes perfect sense to me, doesn't it? So to give you a little bit of information or background on the PDF structure, it starts with a header, or it's supposed to start with a header. I mean, it's okay if the header is within the first 1024 bytes, and whatever comes before the header, I mean, it's okay. So it's not a strict requirement, because, you know, files might end up damaged. Why not? Then you have a list of objects. And after that, you have the cross-reference file, cross-reference section with pointers back into the file where the objects are located. Then you have the trailer, which contains a trailer dictionary. I will get to that. And pointer back in the file where you find the the cross-reference section, and an end-of-file marker. The objects can be either direct, which means they are inlined in the code, or they can be indirect, which means they are numbered and can be referenced from other parts of the from other objects. An example of an inlined object is this 1, 0 object. So the first one is the object number, the second one is the generation number. So you can have the same object defined over and over again, and the latest one will be the one it will work with. This actually led to some, not attacks, but I reviewed a paper where they relied on the order of the objects, and they would use the first one. So, and this was a paper that presented a protection mechanism against malicious PDFs. But then, if you have two objects of the same number, then it would look at the then first object, and the PDF reader would look at the second object. So it could easily be bypassed. I hope they managed to work around that in the end. You reference things by the number, so 1, 0, R is the reference. You have different types: booleans, integers, strings that are delimited by parentheses, and in the strings you can have octal escapes. So \43 in this example, it represents the hash sign. which has ASCII code 23 normally. You have names which are used in dictionaries where you can have hexadecimal encodings. So hash 61 actually represents an A. So the example is /name. You can have arrays of things. You can have dictionaries which are really name-value pairs. And those are what builds up the structure of the PDF file. And you can have streams which can contain arbitrary data. Strings can almost contain arbitrary data as well. It can even contain parentheses as long as they are balanced. If there are an equal number of starting parentheses and there are ending parentheses, then it's still considered one string. So, according to the specification, this is supposed to be a minimal PDF, the smallest one you can make that is valid in the Adobe Reader. Except, they say, that you don't really need an outline for the document if the count is 0. And of course, you don't really need some contents in your page if it's empty, so let's remove that as well. And in fact, you don't really need the resource part of the PDF file if there are no pages. And actually, you don't really need a cross-reference section. And if you don't have any pages, then you don't need to specify the types of the various dictionaries. It will interpret that. It will just try to find, given what is inside, it will determine the type. And in fact, you don't really need a page object. And you don't need to specify the size because you don't really have any objects left, so you don't need to specify the size. You don't need to have an end-of-file marker. You don't need to specify where objects ends. This is more like a minimal PDF. For Adobe Reader, it's okay to not have any objects at all. You can have only inline objects, direct objects, not. And you don't need to specify the version number because it will infer that from the content as well. On the right side, the Google Chrome PDF reader, it almost accepts this small, but you need at least one object. But you can actually manipulate it to use the trailer and the dictionary for the trailer as the object. So you can. This is not really the shortest possible. And on the bottom half, you see the smallest possible PDF that executes JavaScript. Why not have an example of that? Just going to start Google Chrome. So data application /PDF. As you can see, I've done this before a number of times. %PDF. Yeah. Let's see. Actually, Google Chrome is a little bit more relaxed when it comes to the parsing of the PDF file because objects can exist within other objects. So in the stream, for example, of one object, you can have the other object and so on. But let's create a normal PDF here. Sorry. Right. Google Chrome does not like spaces. And there we go. We can add JavaScript execution as well. Open action /s/ A JavaScript warning. On the other hand, Google Chrome the JavaScript is not as powerful as the Adobe Reader JavaScript. So for example, there is no real primitives for communication apart from the built-in PDFs one, but we'll get to that. So we have error-tolerant parsing, which means that this is completely valid PDF code. Can you read it? Shouldn't be too hard. I highlighted the parts that actually are the PDF. So for communication, we need, in order to exploit this, we need communication both with the attacker and with the site that we are, the vulnerable site that we are trying to exploit. And from PDF, we have a URL action that can redirect the browser to any URL. And the problem is when we redirect the browser, it will unload the current document and load some other document. So we will not see the result unless we reload the browser or redirect the browser to how do you say, an anchor on the same page. Then it will not reload and we can actually read the content from the anchor. Same goes for the JavaScript primitives that we can run in the browser. The launch URL will redirect the browser. The get URL will redirect the browser. Submit form allows you to do a post to arbitrary location. But the nicest one is actually the XML external entity, because it allows two-way communication inside the PDF. The other ones redirect the browser, so we lose track of the PDF and the PDF will never see the result. But XML external entity, if we try to parse a string of XML, it will allow us to fetch some more data from the server and interpret it as part of the XML. And this way we can extract that part of data. For example, if there's a CSRF token that we would like to parse, then we can use that token later on to issue more requests or submit forms and completely bypass the CSRF protection. We also have embedded flash again, which is extremely powerful because it inherits the origin of the document, which indeed is the origin that the document was served from, and it allows two-way communication. So with embedded flash, we can do pretty much anything we want. So PDF-based polyglots are easy to inject. The token set overlaps a little bit with HTML, which is somewhat a problem. So it's context dependent. We need to find the context that allows us to inject these characters. And we did a survey of the Alexa Top 100 and found, well, we found actually some that are vulnerable to cross-site scripting. Those were easily injectable. But those are not the interesting ones. The interesting ones are the ones we found that are not vulnerable to cross-site scripting, but are vulnerable to this kind of syntax injection. For example, there was one site that embeds user information within an HTML comment. And as long as there is no end comment in the in this user string, then it will allow any syntax. And of course, we don't need an end comment in order to inject our syntax, so it's completely vulnerable. We found another site that uses the user input in JSON. And JSON is JavaScript, so there's no need to deal with the HTML syntax, the sensitive characters that are part of HTML, and therefore no need to deal with the PDF ones either. And so we could easily extract sensitive information such as the CSRF token or user information. So, and for content smuggling, we didn't, we wanted to do some more tests. For example, we wanted to try out some big submission systems for academic papers, because in these systems there you submit PDFs. And we wanted to try out, but we did not get permission to do that. But it's likely that they are vulnerable to these kind of attacks. Similarly, other systems, we know for sure that Dropbox and Google Drive is not vulnerable because they implement the right mitigation, which I will come to later. But there might be other file hosting sites that allow us to upload a polyglot and pretty much do the same thing there. A PDF-based syntax injection attack would go along the lines of the CSS attack, but interpreted as PDF instead. And the PDF-based content smuggling attack would be similar to the GIFAR attack, but instead submit a GIF that will be interpreted as PDF and then extract the user information and so on. I already mentioned this a little bit, JSON, XML. In the content smuggling attack, it's interesting that the PDF can both be the malicious format and the benign format. For example, we created a Flash PDF polyglot, where the PDF is the benign format almost. What it does is it redirects to itself interpreted as Flash. So you get an automated Flash attack. But it's mostly benign. If you try to verify it, you will only see that it tries to open a link. This would be interesting in the case of, for example, a CV database where you, when you apply for a job, you submit your CV as a PDF file, the reviewer clicks the link, and you make sure that you get the job. So I wanted to give a little demo. And let's see. We still have the good drive here. Here we have a GIF image. We can open it, for example, with Paint. Hello, Bochum. But if we rename it to polyglot.pdf, yes, I want to change it, then it instead executes JavaScript and says hello Bochum again. But that's not all it does. It actually, if we rename it to HTML, yes, it's an HTML page that embeds itself as both a PDF and the GIF image. And here you see some of the GIF syntax, some of the PDF syntax, that is completely unparsable to HTML. But HTML is also a nice format because it allows pretty much anything. It's throw it in there. Oh, I have more demos. You don't see this, actually. This is secret again. Oh, right. Sorry. I should have prepared this before. So I want to first show you. We're trying to exploit here a small cross-site scripting playground where you can search for something and it will reflect the search in the result, both in the value and later on in the page. And this allows us to inject a little bit of JavaScript. Sorry, not JavaScript, PDF. Actually, I'll keep it as it was. Yeah, again, a little problem with the setup, but as you can see, here is part of the page that that was the result. So I will try to go back and so here we inject triviasecurity.org with this PDF, and what we do is this URI action here. It redirects the browser to this non-existent HTML file. So actually, I could change that probably. Yes, of course I can. It's right here in the code. And now we get it in the same domain, so it doesn't redirect to the other side. So that's syntax injection, extracting information through syntax injection. And if this was a more high-profile site with some more interesting content, for example, CSRF token or user information, then we instead would extract that. And this is only one of the many ways that we can extract. So there are others here, as you can see. Just a few of them. This one uses get URL. Here we have launch URL. I didn't mention this one because it doesn't work in Firefox. It works in Safari and Opera, but it's a way to communicate from the PDF with the host container, with the document that embeds the PDF. So how do we deal with this? Well, on the server side, it's quite difficult because we get a user string. We want to use it in, for example, HTML. We make sure that it isn't anything that can mess with the HTML in it. But we need to also take into account any other formats that might be tricky. So for example, PDF. PDF is only one of the formats in a polyglot that could be potentially dangerous. So in general, filtering is too difficult. In the specific case of PDF, then you can filter the PDF tokens that are required to build a dictionary, for example, and the trailer, and it helps in some sense, at least. For content smuggling, both, for example, Dropbox and Google Drive, they are actually Google. They use this GoogleUserContent.com that is a completely sandbox domain. It has no access back to Google.com. And any user content that you put on Google, regardless if it's documents, if it's images, it will be served from this GoogleUserContent.com. And actually how they manage to still maintain sessions across these to limit resources, that is quite an ambitious task. So it's starting with serving content from a sandbox domain, that is a good start, but if you really want to do this properly, then a lot of work is required. In the browser, it would be easier to just have strict enforcement of the server-provided content type and not try to interpret things as what they definitely are not. It would perhaps then, since the server is not always that knowledgeable about what it's serving, it might create problems. And I think the reason that they allow this in the first place is for compatibility. And as usual, when you try to achieve compatibility, then you just toss the security in the bin. And the other, a partial mitigation would be to disallow the type attribute for embed and object. At least that would limit the ways that content could be reused as a different format. For the interpreter, rather, strict parsing would be one alternative, to follow the specification to the letter. That would be a start. Just, for example, requiring that a PDF file should start with %PDF, that makes it hard at least to mix it with other content types that also requires a magic value. But this does not seem to be the Adobe way. So strict parsing is questionable. Another possibility would be since they have a plugin that knows the content type and knows that the content type is wrong, it should not try to interpret it. It should just reject whenever the content type is wrong. And again, that might give you compatibility issues. So far, none of the mitigations are really good enough to completely solve the problems. It's not even a single component that you can be blamed for this problem. I'd like to thank you for your attention, and I hope you enjoy the talk.